to enable the
Yes,
3 volt,
yes.
5 volt section, right? So did you check that, Joe? I told you to check the your schematic and the board. What was the voltage coming at the N trip 1 and trip 2? I think I told you to check about 1.35 volt should be coming there. Did you check that?
Yes, sir. In trip 1 it is 1.3 something like that,
Yeah,
but in trip 2 it is 0.
and that's wrong. It should be both were 1.33 volt, 1.35 volt. Okay, you'll understand how. Today you will understand how both will be that voltage. So
Okay.
did you isolate that point? See, whenever this type of problem is coming, what you have to do is, I'll tell you. Two more members are joining. Everyone in? All are in? I think all are in, right? Hmm. So what I was telling you, that entry voltage, we will calculate it today. What should be the entry voltage 1 and entry voltage 2, and how to determine in different sections. Okay, first let me get some input from you. Everyone is okay with the class? Is it, the voice is good, the screen is good, connection is good, everyone?
Yeah, yeah.
Okay. So I also gave you some homework as well. I think R62,
Yes.
I gave that circuit, that dual BJT. How does it work?
Yes.
And one more
Yes, sir.
homework I also gave. I think what was the second homework? Yes, Lenovo 420 board DC in section analysis. Both of these I gave you to solve. Did you try it?
Sir, I tried the first one. Second
Yeah.
one I did not find.
Okay. First one, what you find? What you found out?
90 volt is going inside. Can you
19
please
volt is
open that
going inside.
schematic?
Yeah, I'm opening. I'm
Yes.
just opening it. And I also put up a question in the group. Did you all read that case study?
In that resistor one,
Yes, sir.
right?
With different value.
Yeah,
Mm.
we'll see that in the charging section, the whole concept. But did anyone find something in that?
Mm. I
Somebody
don't
wants.
have. No, don't have time
Okay.
to search. Sorry, I have a lot of work
Okay,
at
no
the
issue.
moment.
But you have to take some time out as well.
Sorry, bro. I know. It's for
Yeah,
me, but
no problem. Quanta R62, no? Okay, what I will do, because we are energetic in the starting, so I'll start new topic in the start and we'll discuss that homework topic at the last. Okay, so that when we are low in energy, we'll take that. A new thing will start in the start of the class. Okay, so that it is easy for you to grab, right? So I'll start with 3 volt, 5 volt section today, right?
Yeah.
See, what do you know about 3 volt, 5 volt section? What do you know?
after button press, we have 3 and 5 always. 3.3 is the voltage for SIO, and the 5 volt is the voltage we need for USBs. So that is my knowledge.
Okay.
Okay.
So you just mixed LDO and switching regulator. There are two voltages there. LDO is also there and the switching voltage is also there. The regulator voltage, the coil voltage, you should say that. Okay. What you're talking about, the USB, that USB voltage is the coil voltage, not the LDO. And the thing that you mixed with the IO gets the LDO voltage, not the coil voltage. Those two are different things. Okay, we'll see that. Anyone else with a different point of view? Anyone can try to answer. It's not that you will be correct always.
And you say for 2 voltage also available.
Yeah, that's a reference voltage.
Yeah, 19 volt and 3 volt LDO, 5 volt LDO, 3 volt, 5 volt and 2 volt.
That's
It
the
is for
voltage.
charging
Yeah.
AC.
Yeah, this is the voltage that is generated by 3 volt 5 volt section. I'm talking about what are the triggering requirements of a 3 volt 5 volt section, from where it gets its enable, and what are the possibilities of it getting switched. What are the
That
configuration?
3
What are the
volt,
different architectures? Yes.
yeah, 3
Oh,
volt
oh.
enable
Mm-hmm.
and inside enable is there.
Mm-hmm.
One model you showing
Mm-hmm.
self enabling
Mm-hmm.
and entry that entry 1, entry 2,
Mm-hmm.
you say
Mm-hmm.
some controls section,
Yeah.
low logic.
Basically, we will understand 5 different 3 volt 5 volt section architecture. Okay. Each day we will cover different types of 3 volt 5 volt architecture. There are in a general way, if I say, there are 5 types of architecture of a 3 volt 5 volt section. I'm not talking about 3 volt 5 volt IC. I'm talking about 3 volt 5 volt section. IC is a different thing. IC can be of 10 to 15 types, but the logic, the different logics that are possible to generate the 3 volt 5 volt section, that is in general of 5 types that we will discuss. Okay. Right. So who is responsible for triggering the 3 volt 5 volt section?
SI.
enable or EC on.
Always it will be IO.
Pro.
In some cases, entry.
N-trip is always there. Without N-trip, you will not get voltage in 3 volt 5 volt section. Is the N-trip triggering always depends on SIO? This is my question.
3 volt, 5 volt, right?
Yeah.
Because there are 2 types of, one is like always and one is
That is
one
different
type
thing.
of
That is
that is
different
completely
thing.
different.
That is
Okay.
different thing. Whether it is an always, whether it is an suspend, whether both of them always depends on SIO or not. That is my question. Will the
Yes.
IO always responsible for triggering 3 volt 5 volt section?
Yes.
This is my question. Always
Yes.
in 100% case? Everyone
Yes.
agreed with that? But I disagree.
Yeah, you don't
Okay.
know, right?
Because
Please explain why.
yeah, I'll explain. I'll explain it with the schematic. I'll not explain like this only. I'll explain with the schematics. And in the latest generation, this is coming. 3 volt, 5 volt section is itself enabling itself. It is generating its LDO, and via its own LDO, it is enabling its N-trip. It doesn't require IO. That architecture we will also cover. And one architecture you will see in which IO will trigger the 3 volt 5 volt section, and what are the possible architectures of the IO triggering that section. We'll see that in the 4 sections. Okay, what are the ICs that we'll cover in those 5 types? We'll see that as well. The schematics, the different schematics, the generation of the schematics, we'll see that, and the logic and the concept behind that triggering. That is all the overview or the skeleton of the 3 volt 5 volt section that we are going to start today. Okay, so first I'll give you a general perception. What is the general perception of a 3 volt 5 volt IC triggering? Then we'll proceed. This is a small slide that I've made. It was made very long back ago. We'll see it. We'll go through it. This is a simple basic working philosophy of a 3 volt 5 volt buck regulator. Okay, any regulator you take, any regulator, 3 volt 5 volt regulator, it will have these basic points in it any time you see it. Okay, first we'll see what are the uses of a 3 volt 5 volt regulator, right? Where it is used, anyone? As he rightly said, it is used for the IO supply. It is used for RTC section. Okay, it is used for SDSCL pull-up supplies. Okay, it is used sometimes for the power button as well. Okay, in some RAM ICs also, in core section as well, in charging section also. These LDOs voltage are used. Did you see there ACOK? ACOK was having a voltage divider, and there was an LDO supply at the pull-up. That was ACOK having a voltage divider. What was the pull-up supply? It was a 6 volt LDO, right? So that LDO we'll see where it is used. So what is that? 3 volt 5 volt buck regulator is used to step down the DC in or battery supply into 3 volt and 5 volt. You get 19 volt from charging section, and that charging section 19 volt is converted to 3 volt and 5 volt supply. So that's why it is known as a buck regulator. Okay, one is a boost regulator that increases the voltage level, and one is the buck regulator that decreases the voltage level. Okay, so this one is a buck regulator. That's why it is called a buck, because it is decreasing the voltage. How it is decreasing from 19 volt to 3 volt? What is the duty cycle that is required to do that? We'll see that later on when we go into the IC section. After that, the 3 volt 5 volt supply is given to the standby section of SIO, RTC section of PCH, power button, power supply. Okay, these are the common points where you will see this 3 volt 5 volt supply, LDO supply going. Okay, so the requirements, where there is 3 volt 5 volt requirement in the motherboard, you will see 3 volt 5 volt buck regulator related to that. It means what? The 3 volt 5 volt section can have fault due to various sections. Okay, because this IC is supplying voltage to different sections. If say a USB IC has a fault and that VCC is supplied by this 3 volt 5 volt section, then this supply will also get dropped. Okay, so that can also cause a problem in 3 volt 5 volt section. So first we have to understand where these supplies are going. Okay, that is what is explained by this point, right? Then we'll see the input supplies of a 3 volt 5 volt converter. First supply for a 3 volt 5 volt regulator is what? 19 volt, that is coming from the DC in section. Okay, you see that 19 volt coming. See here, this is the 19 volt supply that is coming at the drain of the voltage. Power DC bat out, right? This is the 19 volt supply. It is coming at the drain, and also see here. See here, this one V in. What is this V in? V in supplies what? DC bat out. This DC bat out is what? 19 volt, right? The first supply that is coming to 3 volt 5 volt section is the V in, that is the 19 volt. Okay, right. After that, these are the enabling inputs that are there for an IC, for this 3 volt 5 volt buck regulator IC. What are these enabling voltage, these enabling signals name? EN0, ENM, ENLDO, ENC, and EN. These are the name. Also one name you can add into this, chip select, CS. Okay, CS is also a name that is used for this enable input, the name of this enable inputs. Okay, so these enable inputs can be directly from the 19 volt section. The 19 volt supply that is coming from V in, that will directly go to the enable point. In some cases that can be used for a voltage divider, then an enable signal goes to the supply. Okay, so there could be a different architecture. We'll see all those architecture. This is a general method that I'm telling you, that these are the requirements of basic 3 volt 5 volt section. Okay, first one was 19 volt, second one is enable input. This includes both the enable LDO and the, in some cases these same signal will be used for enabling the N-trip signal. Okay, the next point. Now after getting the LDO, after getting the enable supply for the LDO, you will get 3 LDO supplies coming out of the 3 volt 5 volt IC. These are the LDO supplies. 2 volt LDO, that is the reference voltage. REG 3 volt reference. VREG 5 volt reference. These are the 3 LDO voltage. Remember this. What is written here? After getting enable input from EN pin, 3 LDO voltage will be generated, and these are the 2 volt, 3 volt, and 5 volt LDO voltage. Yeah. After that, this is the point where you will be getting the voltage at the coil of the 3 volt 5 volt section. Okay, first one is what? N-trip 1. N-trip 1 is for 5 volt supply, N-trip 2 is for 3 volt supply. Okay, these two will be generated after LDO. Remember this, not before LDO. These two supplies or these two pin voltages will be generated after LDO. Before these two, only LDO will be present. So Whenever you check a 3 volt 5 volt section, first check the LDO. Is it coming or not? Then that part is over. After that check your coil voltage, whether the coil voltage is available or not. Okay, right. Now this fifth point. After the entry voltage is present at pin number 1 or 2, whatever it may be, the pin number 13 or 2 pin number, you will get the 3 volt 5 volt output at the coil of the regulator, both the coils. Okay, and there will be a feedback pin. Okay, that pin is really important in 3 volt 5 volt section, or in any regulators, for a matter of cause you take, any regulator will have an adverse effect if its feedback signal is not working well. Keep this in mind. Feedback is really important in these regulator ICs. Okay, how it will work, what is the requirement, what are the faults that will be generated by this point, and how to solve those faults. We'll see that later in the next part when we go to the schematics, right? So these feedback pins, that is used to determine whether the power is good at the coil or not. You see, a power good signal is generated by a regulator IC. Whenever you see a regulator IC, there is a power good signal. What that power good signal, how that power good signal determines that its output is good or not, that is determined by its feedback. Okay, and the power good signal is approximately 96% of the rated voltage. Okay, if you have, say, if you have 5 volt output at the coil, then when a power good will be generated, when there is a 96% of the 5 volt, up to that point you will get a power good supply. If the voltage at the coil comes below 96%, then there will be no power good at the output. Everyone clear with that? So what is the 96% of 5 volt? I think 4.64. Calculate please. What is the 96% of this 5 volt?
4%.
4.8.
4.8, right?
4.8, yes.
Yeah,
correct.
so if you are getting up to 4.8, then it's good. Somebody asked me what should be the voltage that we identify as to be a correct 5 volt. Up to 4.8 volt, you will identify that to be a correct 5 volt supply. If it comes below it, if it is 4.7 or 4.6, then that is not working good and you will not get a power good at the IC. Got the point what somebody was asking previous class, right? Now we are done with this. This is a small overview of
Thank
the
you.
IC. Yeah, now we'll go to the IC, working of the IC. Okay, see here. As I told you, there are 5 types of architecture that we'll see. First, I'll list those out. Then, after listing those out, we'll see one by one. Okay. See here.
So different architecture.
Okay, we'll see the different architectures of 3 volt, 5 volt section, right? The first one is the simple one. It is what? SIO triggered. Second one is what? Non-SIO triggered. Okay. In this SIO triggered, this will be a single category. This will be a single category. This will contain what? Self trigger. Self trigger 3 volt, 5 volt section. Okay. It will be a self trigger 3 volt, 5 volt section. Okay. And the SIO trigger, this will include what? This will include PSL logic. You will come across PSL logic. What that PSL logic, how that will trigger the 3 volt, 5 volt section. You will also come across the Ntrip SIO interface. Okay. You will come across self Ntrip. You will come across SIO direct triggering. Okay. This is what, this is 1, 2, 3, 4 and 5. Total 5 architecture that we'll see one by one. Okay. First, the simplest of all, we'll see with the SIO direct triggering. This is the simplest of all, SIO direct triggering. How a SIO directly triggers the 3 volt, 5 volt section. See here, I'll cover a small part or the basics of the SIO triggering, very basic, that is required for the 3 volt, 5 volt section triggering. The complete SIO will be taught by Nasir sir. From the next week, he will start taking classes. Okay. So in the next week, he will start the SIO, the complete working of the SIO, how it works, all the LPC, the PCI, the sus clock and all the RTC section, how they are interfaced with the IO. He will take care of that. I'll take care of that of the part that is used in the 3 volt, 5 volt section. Okay. Whatever part is required for the 3 volt, 5 volt standby section from the IO, I'll teach you that. Okay. After that, we'll see. He will teach you. He will teach you the rest part of the SIO. So what is required for my part is that, see here. As I already explained about the always and the suspend supply. Okay. We came across that always supply and the suspend supply. Okay. So if there is an always supply, how the 3 volt, 5 volt section will be triggered, that will also see. If there is a suspend supply, then how 3 volt, 5 volt section will get triggered. We'll see both of the cases in this direct mode. We'll see both the cases. Okay. So I'm taking just one case right now. For an IO to get trigger, the first requirement is what? AC in. Okay. This is what? AC in. Or you can also sometime take it as AC OK. The second requirement is power button. Okay. These two are the basic requirements of the SIO. One requirement that is also defined in it. See here, there are two parts in SIO. One is analog part. One is what? Digital part. One is the analog part. Okay. So one is the analog part, right? And the second one is what? The digital part of the SIO. We are talking about what? SIO. Right? So we'll get a supply here also. This is an LDO supply, the 3.3 volt. Right? When these three supplies, 1, 2, 3, when these three supplies are met, then you will get a signal called EC on. Or you also call it as S5 enable. Okay.
LDO 3.3 AC in.
AC in, power button, LDO. These three, yes, these three is required to generate the EC on, or you sometimes it is also called sys on, system on. These three are the names of the signal that will be generated. This signal will go to enable the 3 volt, 5 volt section. Okay. This is called direct enabling. This is called what? Direct enabling. IO is directly enabling the 3 volt, 5 volt section. Okay. Right. So this is the basic requirement of the IO to generate EC on. I'm not talking about the RSM reset. I'm not talking about the SUS clock. I'm not talking about EC reset. I'm not talking about all those things. That is also generated. I'm not talking about 1.8 volt that is generated in the IO. We'll not talk about that. It will be discussed separately because that requires a separate class. It is not related to 3 volt, 5 volt section. Whatever is related to 3 volt, 5 volt section, I am dealing with that only. Okay. So these three are the basic requirements that you need to check before EC on is coming or not. Okay.
Sir.
Yeah.
Sir, you have written, so SIO is generating EC on S5 enable, right? But under it you have written sys on direct enabling. So what does that mean? Can you please explain?
I have put a slash mark here. These three are same.
Okay. Okay, it's all the same.
All the
that
same
means,
names. Yeah,
okay.
it's all. This could be a different name in different board. Okay. If you see sometimes sys on doesn't mean that it is not EC on. It is also an EC on. Okay.
Perfect.
Yeah, that's an output of a SIO. These are the output of an SIO. Okay.
Yeah, I understand.
Yeah. Now we'll go to the schematic. The first schematic. My favorite board. 3521. So this board is a always or suspend, anyone? This board is an always board or suspend board? Anyone want to say anything about that? It's an always board or suspend board?
I don't think we have enough experience with that board.
I don't know.
Check. I told you to check. I told you to check. Okay, no problem. Do anyone know about deep sleep well? Deep hour okay? All these points? Do you have any idea about that? Deep sleep well, active sleep well, SUS well, deep hour okay, DSW? No idea. Okay. No, it is not needed here. I was just trying to ask from you. Okay. See, we'll leave that apart. We'll just focus on 3 volt, 5 volt session. What we'll do is that we'll study everything separately and then we'll amalgamate that so that it will become a circuit, a closed circuit, so that you can relate each other. Okay. If you try to intermix everything, you'll get confused. If I asked you deep hour okay right now, you'll get what is that? I don't know. Then you'll get confused. So forget whatever I said. I just wanted to have some input that I know more than you. Okay. Now see here. What is the first requirement that I told you? First of all, remember one thing. What is the IC number?
RT8205.
This is what? RT8205. See here, there are various versions of it. L, Z, Q, W. These versions could be different. Okay. It could be A as well. It is L. It could be A, B or C. Okay. In different versions, you will get different pin configurations. Okay. See here, in this 18 number pin, it is no connect. Okay. If it is A, B or C, sorry, A or C, if it is RT8205A or C, you will get here what? A clock, V clock. You will get a signal here, V clock. That will be responsible for generating the 14 volt that is used in the run section in the S0 state. Okay, it is not used here. So that's why I'm telling you, don't just see the number RT8205 and just put the IC and put it here. And you asked me that it is not working. You have to understand which pin is working for what purpose. You have to match that as well. Okay. So for that you have to understand if it is no connect, then what you have to do, if you have used RT8205A, then what you have to do, you have to put that pin up from that point. Okay. So that it is not useful there. Then you can use it if all the pins are matching there. So it's what is the number of pins in this IC?
24.
It's a 24 pin IC.
20.
24
yes, on the
pin
last.
IC.
25.
It's a
25.
pad. It's a pad. Okay. Okay. I accept. Basically, it's a 24 IC, 24 pin IC. We call it 24 pin, right?
Mm.
Why we call it 24 pin?
Because it is 24 pin.
It is inside. It is pad. It is inside
Yeah,
the IC.
it's a pad. Yeah,
Okay.
yeah.
See here, 3, 3, 6. 6 4s are 24. It cannot be a unsymmetric IC. Any IC cannot be unsymmetric. Okay. Either it could be 20 pin IC or 24 pin IC. It cannot be 25 pin IC. Remember that. Okay. This is a what? QFN model. QFN model means what? It's a quadrat. I understand that. It means, what does it mean? It means that it should be a symmetric one. Okay. So symmetry means what? If 6 pins are here, 6 here, 6 here, 6 here. So it's a 24 pin IC. It's a pad which is connected inside the IC, beneath the IC. Okay. For connection. Right. So what is the first requirement that I told you to check?
The first requirement, AC in, which is AC okay.
No. Is it IO?
VN.
Is it
Oh,
IO?
no. Okay. Sorry.
It's a 3 volt, 5 volt section. So
Yeah,
the first
sorry.
requirement was V in. What was the first requirement? It was
V in.
V in.
In.
This is a 19 volt supply. Which is the pin that you have to check? This is the 16
16.
number pin.
16.
Okay. Where it is coming from?
B++.
B plus. So you have to check on the capacitor PC218.
Hmm.
At the capacitor PC218, you have to check 19 volt is there or not. Okay.
Yes.
First point is 19 volt coming to this V in section. What is the second point that I told you?
Enable.
Which enable? There are two enables.
Never 0.
LDO, EN, ENC, EN0, ENM, ENLDO. That is what I told you. This is the EN.
Yeah.
So where it is coming from? It is coming from this B plus. This is a voltage divider. Then this signal is going here. But these all are at the rate. Can you see it?
Yes.
These all are what? At the rate. It means these components are not there in the board. Okay.
Sorry, can you write this word add rate this here somewhere? I want to add rate. How to write it?
Okay.
I know. I see this. I know add hash bar. Yes, but add rate.
Okay. I'll tell you. You have to write just A. You write A.
Okay.
And then just
okay,
make it like this.
Okay, add rate.
Write A and just make a partial
A.
circle.
Yes. Okay. Add rate is okay. Good. I have.
Okay.
I finished.
Right.
Thanks. Sorry, guys.
No problem. So see here. This enable. This is the enable.
Yes.
Okay. So this LDO enable. This LDO enable is controlled by which signal then? V in. Directly by V in. Are you getting the point? What I told you, enable signal, the LDO enable signal will never come from IO. That is what I told you. Okay. The enable signal, the LDO enable, it will be self-enabled or by V in. How I am saying that? I need to give you the proof. Wait. We'll go to the data sheet. Okay. Will not work like this only. We'll get to the logic. See here, what I told you, ABC, I told you something ABC.
Yes.
See here. This is what L. This is what M. I'll give you the A also. See here, ABC. Can you see it? ABC.
Yes.
Yes. So there are 4 versions. You have to see what is the version that is in your board. You have to match that. Okay. Then it may not work properly if you do that. If you do some R&D, it may work, but directly it will not work. Okay. So you have to just keep that in the back of your mind whenever you do this. Okay. See here. What I told you, this enable signal. This is the enable. This is the internal logic. Okay. This is the 8205 internal logic block diagram. How it is working. Okay. See, this is the V in. Okay. this VIN is also going into this switching logic, and this enable is also going into the switching logic. Okay.
Yes.
So IC has the authority that it can choose either of them, from the enable as well, from the VIN as well. Okay, that is decided by the manufacturer. If he wants to enable the IC by enable pin, then he will provide the supply from the enable pin. If he wants to enable it from the VIN supply only, then he will remove the enable pin and he will directly supply from the VIN supply. Getting the point what I'm saying? So whenever LDO can be enabled with VIN supply as well. Never 3 volt, 5 volt will be enabled with VIN supply. Remember this point. Okay. 3 volt, 5 volt coil voltage will never be enabled by 19 volt VIN supply. Okay. It will require a different logic other than the LDO supplies. Getting the point what I'm trying to say? Yes. See then. See here. So in this board, this enable pin is not required, but in some other board you will see this